Hello. So today I'm going to show you about some project which has just got. So here you can see that it is about the traffic light control. On looking into it, it seems a very easy project, but it's not because it's all to be done in the structural code. So this will be the top level module in which it says that there will be only two inputs, which will be the clock and the reset. Reset will be a push button, or but here it says that it should be a push button. Okay. Okay. Now what it will be just doing. So if we see that, let me just show. If we see here, so it shows that the clock input of the FPGA is 50 megahertz. So it will be driven into a clock divider. Okay, the reset will be connected to the core logic and the clock divider. Now the output here, the sync clock is optional. The 1 hertz clock is mandatory. So this clock will be driven into the core logic, and inside the core logic there will be another module instantiated, which is counter unit. Then the output will be as a 6 bit for the control signal. Then decoder will take that control signal and it will decode and it will disperse the values, the outputs to the 7 segments and LEDGA and R. So green, amber, and red. Okay. Now just think that the input to the decoder is 6 and the output is 7. So this is how we have to decode it. Okay. Now what? Okay. So let me just show you that we have the description of each module that what it should do. So this is basically normally to convert the 50 megahertz to 1 megahertz, right? Okay. Also, the reset N should be active low because the push button which is being used in the FPGA works as a active low. Okay. What does the core logic do? Now, here is the signal. Okay. So, core logic will have only the input of clock and reset. There will be a 6-bit output. Okay. So, which will be controlling the thing. Now, it says that according to these all, it will, like you must construct a 6-bit control signal which include information about the current working traffic light, which is red, green, or amber. Okay. So it means that there should be a where it says like a state machine inside this 6 bits, okay, and also that 6 bits will also have the timer, okay. Now see here it says that, for example, the initiative color is red, okay, so red will stay on for 10 seconds, then amber will stay for 3 seconds, then green, then amber, then red, okay. So like amber will be turned on after every 10 seconds. Okay. So it will be repeated after each color. Now, like this. Okay. Now, in counter unit, it says that here it says that a counter will be used inside the core logic. Okay. We have checked that into the core here. Like, I'll just let you know, in the top level, because the counter is used inside the core logic. Okay, so that's why there is a note that this should be used inside the core logic. Okay, okay. Now, here, what this is just doing. So it says that this customized counter should be counting upwards. Okay, so like if it is zero, then one, two, three, four, five, so like that. Okay. Now in the decoder, this will have the output. It will just like disperse the things that how they are just working. Okay. Also, the counting will be on, like for example, it will start from as in the counter logic. It shows that the counter should be upward. Now here it shows that the counting should display should show the downwards. Okay, so it will start from the 10 or either from the 3. So it depends upon the color of the LED. If it is red or green, it will start counting from the 10, otherwise from 3. Okay, so this is how it's just working. Here's a small thing about the 7 segment, that the 7 segment will take only input 4 bits. Okay, but the 7 segment H high, okay, the high digit will be shown and the lower digit should be shown. So how this is going to be done? It's all upon the thing. Okay, so I have done this project. Let me just show you the RTL viewer. Okay, so if we just look into that, okay, let me just show you. So it says that the 50 megahertz should come up. So this is the 50 megahertz coming up. Okay, it is a clock divider. The clock divider output is going to the core logic. It's going into the core logic. Okay, also the reset is connected to the core logic, right? Then the core logic output as 6 bit will be connected to the decoder, as 6 bit connected to the decoder. Then these decoder values will be dispersed into the other thing, which will be 4 bit for the 7th segment, right? Then 113 other output will be for the thing. Now, this is how I have done. So, also, one more thing, if ever you want to have this code, just text me on my WhatsApp. My name is Wajid Khan, right? So, I can give you the codes or I can just modify the codes. I can do everything for you, but not for free. Okay. So, this is my WhatsApp number. Okay. You can contact me anytime. You can just text at me. Now let us move towards the FPGA term. So let me just show you that how FPGA works. Okay, so I have pressed the reset and now you can see that this is like the red. So when I just leave the button, so it will start counting. After 10 it will go to the amber, which is the second light, and the other one will be for the okay. So now green. When the countdown is completed, it will go to the amber again, like this. Okay, I have also converted this to this, like on the real LEDs. So let me just show you this. So suppose this is a green. Okay, then I don't have the yellow, so suppose this is the yellow one, then the red one. So this is how it is working. You can see, right? So the red one, now the yellow again for the 3 seconds, then the green, and this will be as repeated. Okay, thank you.